Hey physics kids, here is your first edition of Yo at Home, and right now I want to cover a subject we need to talk about in wave understanding called index of refraction. We've talked about refraction, but now we want to put some mathematics in it. An index of refraction is a way of comparing the speed of light in a vacuum over speed of light in a substance. And it's a ratio. Well, where does light go fastest? Ta-da! In a vacuum. That means this number is always going to be larger than this number. What does that mean? That the index of refraction will always be larger than 1. Because if you have the fastest light can be, and it also is going over the fastest light can be, that will equal 1. All right. So the index of refraction is going to be a unitless number. You can tell right away. Speed of light over speed of light. Meters per second over meters per second, that cancels. So n is a unitless quantity. Remember the other unitless quantity we have? Anybody? Come on. What's the other unit? Yeah, excellent. The other unitless quantity we have is the coefficient of friction, mu. So this is the other one we have, which is n. And n is properly given c over v. Simple as can be. So let's talk about the speed of light in water. Well, what is the speed of light in water? Well, if you look on your reference tables, you'll find the index of refraction of water, n equals 1.33. So let's put down some givens and see what we can get for the speed of light in water. So if n equals 1.33, the other given we have is c. c equals 3.0 times 10 to the 8 meters per second. That's the speed of light in a vacuum. And we are looking for the velocity of light in water. Let's look at the formula. Formula then, n equals c over v. Let's rearrange that and solve for v. And v is going to be c over n. Following that? Right? We just did the swapping. All right? And if you want to do it properly, you could say times v and times v, and the v's cancel. Now you have v times n equals c. And if you then divide both sides by n, whoosh, cancels here, and you have c over n, v. There you go. v equals c over n. Good. So let's go to substitution and solution. v equals c over n. And you can see this is pretty straightforward. 3.0 times 10 to the 8 meters per second. Let's bring you over here. Divided by 1.33. That's all there is to it. Little calculation. You tell me what that equals. But that's the speed of light in water. You can see the units are carried down because there's no units to cancel out there. And that's how you'd find the speed of light in water, or the speed of light, dare I say, in anything. What is going to happen when it slows down? Right? So imagine a beam of light. If this is the surface, this is air, and this is water. And I'm going to construct a normal here, because remember, all angles are measured with respect to normal. If a beam of light comes down and hits this interface, which way is it going to bend? Here's the incident angle. All right? Is it going to bend outward, away from this normal? Or is it going to bend inward, closer to the normal? All right? Well, let's take a look at this. If you remember, make the front of a Jeep. This wheel is in the water. This wheel is in the air. Which one is acting like the pavement? In other words, which one has it moving faster in? Clearly the air. So it will rotate the vehicle this way. Therefore, you can predict this line will come down closer to the normal, and the angle of refraction will be less than the angle of incidence. And that is indeed correct. And in the next section, I'll show you how to calculate that. Thanks.